Okay guys, today's video is going to be a follow-up to the last one. I'm going to be doing a side-by-side comparison of the TVS diodes that are currently in the M150 and going to compare those to a 30 amp Schottky diode, which I think is the better selection. And just going to do a simple little voltage current test here, and what we're going to see is how much voltage does it take to pop a 3 amp fuse. So was going to scale up and do the full 30 big show, but it's just too much because my power supply wants to current limit it at low voltages, and I'm not going to be able to do a realistic one. So I just scaled it back down to the 3 amps here, and but it still shows the same exact effect, and the point will be made. I'm going to start off with hooking up the Schottky diode here, and I'm going to adjust the voltage until I get 3 amps, and then take it off, and then bump the voltage up some and shock it back, and we should be able to see the fuse pop at that point. And I'll do the same test for the TVS diodes. So let's just get going on this. I'm going to go ahead and hook up the diode here, and I'm going to come over here. I'm looking at my voltage and my current, and I'm going to adjust my voltage up until I hit 3 amps, and then I'll disconnect. So here we go. I'm coming up, and there's my 3 amps point right there. I'll stop, and that was about 0.67 volts was what I needed to get to the 3 amp mark. So what I'm going to do is I'm just going to go ahead and increase it to a couple more, and put it back on, and go ahead and pop the fuse, and that'll be our reference. So we hit 3 amps at about 0.67. So let's go ahead and crank that up to about 0.87, and that should be more than enough for us to pop the fuse. I got my current limiting maxed out. It's only a 5 amp supply, but I should be able to hit the 4 amps or so that I need here to pop my fuse. So here we go, and you can see some of these fuses have really slow responses, so I'll take that back off there. Even though we were drawing more than 3, it's kind of a good demonstration of how these things need to, if you don't shock them with a big one, with a big voltage, it'll sit there and boil. So let's crank this up to right at 1. And we'll do another shock test here and see if we can't, how quick we can get it to pop. And there's 4. And as you can see, the fuse, it's not opened up. So we'll take that off there, and we'll crank it up some more. I'll go up to 1.2. Alright, now here we go again. And I can hear the fuse bubbling. You can actually see it aglow. It's burning, but still not popping. So I'll go ahead and take that off. That's the other thing too, is you got to be careful about the manufacturers of these fuses. I don't know what their tolerances are. Well, let's go ahead and go up to 1.5 and see if we can't shock it apart. There's it up, and it finally went. Okay, so that was a cook-off at 1.5, but it finally went. So let's go ahead and turn that down. we'll pull out the fuse, get in a new one, and then we'll replace the diode here with the TVS diodes. Okay, so I got that in there like that. I got this. Now let's take this diode out, and here's our dual TVS diodes there in parallel, just like they are in the setup. So let's get hooked up there. Okay, so we're all hooked up here. Now let's do this test again. I can already tell you from messing with it previously that I have to go to the higher range to get the current up. So anyway, we're hooked up now. We're going to do the same test again. We're going to go ahead and just slowly crank it up until we get 3 amps and get a measurement at that point. On the last diode, we were like 0.67. Something like that. So we're going to do, like I said, the same test here, and we're going to crank up until we get right at 3 amps. There we go. Okay, and that's about 1.9. So you can see that was a significantly higher voltage than the Schottky, almost 3 times the amount. About 3 times the amount. And I'm putting my finger on the diodes here just to be a human heat sink and take the heat off of them. So there's the 3 amp measurement on the TVS's. Now let's go ahead and do the same thing that we did on the last one and crank it up. I'll go ahead and take it up to 2.5 and see what kind of results we get there, and see how much we can take before we can pop the fuse. I can see the fuse melting and getting hot and glowing, doing like it was doing the last time and bubbling, but still nothing. So let's crank that up to 3. And now we're going to do the same test again and see if we can't pop it. Okay, it's glowing, glowing, glowing. Pop. There we go. So it took about 2 or 3 seconds, and it finally popped. So okay, so that's a side-by-side demonstration showing the differences in voltages needed to pop the fuse, and you're seeing, like I said, about a 3 times the amount of voltage needed for the TVS diodes than for the Schottky. So I want to pause here, and then I'll do a little demo with the 9-volt batteries here and demonstrate the reverse jump start. So stand by. Okay, continuing on. I have 2 9-volt batteries here, and I'm going to use these to demonstrate the effect of a reverse jump start. So I have one that's slightly lower. It's depleted compared to a brand new fresh one. So let's just compare the voltages on the 2 to start off with. So we'll get a fair comparison here. So let me get this lined up. So on this one we got 8.86, and on this one over here we have 9.26. So this is the good one. This is going to represent the battery that we're going to use to be the donor for the jump start, and this is going to represent the dead battery that's that we need to give a boost to. So I'm going to start off by connecting here, and let me just go ahead and get on here like this, just so we have some nice nice voltages to look at there. Okay, fantastic. So there's our situation, and we're going to come up, and now we're going to do a jump start. So we're going to connect our negative over here to our positive, which is what we shouldn't be doing, but this is the test. And here we are with our second jumper cable and on the good battery, and we're getting ready to pop. Now what I want you to look at is as I touch the clip here to the battery, you're going to see the voltage on this drop, and it's going to drop all the way down, and the two voltages are going to cancel each other out. And the superior battery on this side, its voltage will be stronger, so we'll see a slightly negative voltage result from these two as they're discharging against each other. So here it goes, and there you go. You can see it 4.0, and this is as this battery right here is discharging into this battery here. Now I hooked up an oscilloscope to it and did a screenshot kind of thing. You would actually see that when it first started out, it was like 1 volt, and then it quickly climbed up to 4. The fluke meter over here isn't quick enough to catch that, but that's what it was. Now I can demonstrate that better if I take another fully charged battery and put it next to it, and then we can have an actual a fair war, if you will, and we can come over here, get this on like that. Okay, now there's a 934, so we have a 912 and a 934, and these are both charged batteries. So you'll get a little spark here when I clamp down, but you'll see the voltage is a lot smaller, and because this one is slightly higher than this one, we won't see the negative side. We'll see it just slightly more positive, but you'll get the point. So anyway, here's the second 9-volt battery, and here we go. Boom, and you see it slamming down, and that's what the radio in the vehicle would end up getting. That's the voltage that it ends up seeing. So just keep in mind that the two main voltages cancel out, and whoever's the strongest left, that's the voltage that'll dominate whatever the difference is on that. So I hope that clarifies it for you, and so you get a firm understanding that reverse jump starting is not at all the same as hooking up a battery in the reverse position. So all right, that'll do it for now. Thanks.